Hello lads, today I'm gonna show you my code that I wrote for Perspex problem sheet. As you can see, here is the code. I'll just scroll through it very quickly. Uh, it's not the smallest code, as it consists of 209 lines, and that includes of course spaces or new lines that weren't used. Uh, I actually included the new lines because it's easier to see different parts of the code, to identify different parts of the code, of course. Um, and we'll see what the code does. But first of all, I'll show you my data, where my data is located. It's located in this folder called data 11. That's the one I was working on. So as you can see, there's only that file, that is a data file, and text file, txt file, that corresponds to the data file. Um, so I'll use this in my code. So let's run the code. First of all, it asks me to select a file. As you can see, it's only that file that I can select right now. So I'll do this. Uh, it reads the data file right now, and you can see it says busy, so it reads the data file, um, and after it finishes, it gives me this beautiful figure that is the data against time in seconds. It's all labeled. The figure is labeled, not the axis, of course, but it's the amplitude of the signal against the time in seconds. And yes, it is 35,000 seconds. It's pretty long time domain. Let's close this because we got a new file selection, and this time we're asked to select a text file. So let's do this. As you can see, it gave me it gave me this new figure uh, that is just impurities over 30-second time period, um, and each impurity has been identified with a text file, because in the text file uh, it's the old sensor that reads 60 to 30 seconds later after the new sensor, and what we're trying to do is we're trying to just figure out when the new sensor happened, because it happens earlier than the old sensor. So I just plot this. I just see where it occurs. I just plot the 30 to 60 time domain and see where this occurs. As you can see, it's like spikes down there, and there's a spike down there as well, and there's one. There's also another figure that I will show later. It's the same figure as figure 2, but it's the FFT of the same signal. So I'll just check the frequency domain. Uh, it asks me for another dot file to select. This time it's the data that has to be analyzed without any text files or anything like that, without any help. And I'll select the same data because I know when the impurities occur for this data, so I can check if they occur at the same time for the same data. Kind of double checking. And let's select them. It again loads the file and reads the file, so it's busy for a moment, for a few seconds. And there you go. That's the new data that I've loaded, that was analyzed. It's initially the same data as the first one, as the first figure. As you can see, yeah, it's exactly the same data. What I was trying to do is I was trying to make sure that my code works for the same type of data. So that was the figure 5, and the other figure that was opened, it's FFT of the impurities, of the found impurities, autonomously found impurities. As you can see, it's just the spikes at different bins. I could have done a frequency for them instead of bins, but it wasn't that necessary for my project. So here you go. Now let's see what was written in the command line. Uh, the code starts in here. So there you go. That reads the text file and prints out just the things from the text file. I'll open the text file right now. There you go. That's the text file. And as you can see, I just took numbers from text file and wrote it to the matrix, and then I displayed this matrix with some text. So as you can see, it's just the type of impurity and what time it occurred with the Hall sensor. Then I analyze the data and see when those types occur. And you can see type 1 occurred at 264 seconds with the new sensor, and it is approximately 40 seconds. Yes, approximately, well, even 44 seconds earlier than the old sensor, because old sensor occurred at 308 seconds. And yeah, it just makes, it just identifies where the impurity occurred. Then my code actually reads autonomous data from this spikes and see if there's an impurity occurring. So an impurity is usually a high spike or a high impulse, like there, with a bit of low spread range of numbers at the end. I'll just zoom out. Yeah, see, it's a bit different from the main data. Please mind that data like this, it's not an impurity because it's not high impulse. It's actually many impulses consistent in just one. Also, there was not an impurity, but another high impulse that pretty much looked very similar to impurity. It's something like this. But if we zoom this in, we can actually see that it's a range of values. Once again, it's not pure impulse or just a pure spike. It's not one spike. It's many impulses. But let's just zoom in closer and see how my data actually is being detected. When I zoomed in, I actually noticed that when an impulse occurs, there's usually a very low value, lower than the main value. The main value is between minus 0.2 and 0.2, so it is lower than main data. That's where the impulse occurs. But then the n-1 sample is very high, higher than main data, and n+1 is higher than main data as well. So I use this in my code down there. So as you can see, the end file has to be smaller than 0.3. I assumed that the main data was minus 0.3, so that I could actually get a bit of bigger error. And then, as you can see, data n-1 has to be smaller, or sorry, bigger. So has to be bigger, and data +1 has to be bigger than main data, which is what it is here. It just identifies these peaks. And as I said, it prints out the end sample when it occurs. Then I create another matrix that just prints out the type corresponding to those seconds. How I got seconds is pretty easy. I just got the end sample and divided that by the f, or the sampling rate, which is where did it, yeah, down there. See, I just changed the end sample in matrix to seconds. It was pretty easy. And now what I do, oh, before, yeah, how did I identify different type? So first of all, I loaded this. I took readings from from a matrix, and I created a new matrix called A2. I copied everything from A2, and then I just looked at the FFT of each impurity, or sorry, at the matrix. and see if they have something in common. For example, if type 1 is common to other type 1s. And I just assign values to specific bins, or FFTs as you call it, to different types. So type 1, assume it is this, type 2, type 3, and so on. Then I actually check, for the new data, I check if this is uh, in the same domain of bins, like this. If this uh, corresponds to anything of this, or a type of data. And I also assumed there could be an error. So my error was 5. So 5 bins on one side and 5 bins on the other side from the impurity. So assume that it could be a bit smaller or a bit larger. And then I just check if it is that or that. I assume it's one type, and so on. So then my code writes data to the file. That's the whole bit. In the same format as it was opening my text file. My text file is just down there. See, that's the text file that I loaded. And now let's see. That's the one I've created. See, my code actually creates the another text called data analyzed, which is in the same folder as the data I loaded to be analyzed. And let's see what it is. Oh, look, it just identifies different types correspond to different seconds. And my code doesn't work 100% as I would like to, but yeah, see, it says type 0. Why is it type 0? I will say why. If we load FFT of the last one, you can see that maximum occurs at this point, which is never happened before. What I have should check, what I have shouldn't check, is the impulse of FFT as well. So see, it it had to be this this value, but it didn't happen because the maximum value is different for this one. So yeah, it's one error out of 20 samples, if I'm not mistaken. It's not bad, but it's not the best as well. So yeah, so I guess I've showed everything. Oh, I've also wrote another code for data 6, which is very similar. Let's just clear this so that it's almost exactly the same, but the main difference is how the code identifies. See, that's my identification part of the impurity. So that is different for any for different code. Please mind that, because my code is not an universal code that can work with any kind of code, or any kind of data. Sorry. So I have to actually manually write this and then check for kind of each of the impurity. Okay, let's go ahead and let's run the data 6. Just a quick review. Yep. Also, I'll just delete this. And let's see if there's something for data 6. There's no text file that was analyzed for the data 6. So let's run the code and see how it works. Again, it's the same procedure. Ask for the data file, upload the data file, reads the data file. Takes a while. There you go. Read the file. Now I select the text file. There you go. Once again, what do you say? Now I have to send the data again to be analyzed, and it's the same data. I just want to make sure that the code will work for a similar type of impurity, so I load the same data. It does the same thing as the first data, analyzes it, takes a while. Let's see what it does. Oh, it gave me similar. It's not the same. See, the data is different. Impurities doesn't happen on high impulse anymore, or very low impulse. There's nothing on the impurity. Let's just zoom in. The impurity is for this type of data is just three values, three higher values that occur higher than the main data, and then the the data that is on both sides of the impurity is pretty low. I'll just zoom in just to make sure. See, that's the point that happened at 2886.83 seconds, which is, if not mistaken, is 288,788 third, sorry, sample. There's another data, as you can see, that point, because it's not a straight line, it bends, and there's another data. So it happened to be 3 lines, and most of them has to be higher uh, than the main data. I'll just zoom out and see. Just make sure. I'll probably do this data as well, so that you can actually see. Okay, see the data or n sample happened down there. 3 of the samples are pretty high. So yeah, the code is just working out this. Let's see if there's something. Oh, there you go. There's an analyzed text file that was created. This please mind that for this type of data, my code works perfect. So there's no 0 types of data, because the data is pretty consistent. You can identify pretty well for this type of impurities. So let's just close them all. I think you got the idea what the code does. Let's just open data analyzed. Oh, sorry, it's been open already. And let's open the data that we had, the text file that we had with the data file. Okay. It's pretty weird. I cannot open the second window. There you go. So as you can see, that actually reads earlier because the data is 63 seconds earlier. So it always happens a bit earlier, as you can see. To be sure that this is 100% right, I'll just go to data that was analyzed and see if that corresponds to any kind of purity. So that's 578, that's 578, and that's 2888. Yep, 448, and you can see it is pretty consistent for this kind of data. Yep, it works pretty cool, and everything's perfect for this kind, not for the main part that I had to do. By the way, data 11 was my main data that I had to work with, while data 6 was my decision to do it. I just wanted to see if I could make a code that could work for other data rather than mine. So I did, but the impurities has to be analyzed. Our impurities have to be analyzed by hand and see what properties they have, which is the downside of this code, of course. If I had more time, I'd probably do fully working code for all the types, but I didn't have, so I did my best, what I could. If you need data as well as the code, I will include links to them in my or in the description of this video. That will bring you to my Google Drive, and you'll have everything in there. So yeah. Also, just a quick note. I have some notes on my code, just so you could understand what a particular bit of the code does. But there you go. Thank you very much. I hope you enjoyed. See you.